Alrighty, welcome back my YouTube followers. Today is a couple days of putting together some of the things that I've been coming up with and noticing, and today is a day of going over some of the things I've learned. So I'd like to say hi to everybody. Thanks for my followers. Let's give a shout out to my boy Scott, my boy Woodruff, following your stuff. Nice work, man. My boy Abraham, great work. I love it. Keep it up. I'd like to say hi to my boy Clay. Deeds, you're doing a great job out there. You don't know how much of my other stuff that I work on reflects off of some stuff you've been working on. You too, Woodruff and Abrams, man. You guys got it going on, man. You guys got it going on. So today, back to Eds PMH wheel. This replica with 24 poles, each magnet are grouped together as this is a double north, a double south, north, south, north, south. And today we're going to talk about the strength of these magnets. If you notice, I have little keepers that I had made, and of course they stick, but there's not really a lot of strength with these guys, okay? Not a lot of strength. Now, of course, slamming a lot of amps and stuff at it and getting it turning, these magnets are all whacked out and kind of beat down, I would say, destroyed a little bit. So basically I have to recharge them. I'll use the PMH. It charges these magnets perfectly. The more amps you put into it, the stronger the magnetic field here. But it's not really important here. As I go through some of Ed's writings today, I was in his magnetic current, and I was looking in an area and reading in regards to when he's making his PMH. And what I realized was I'm showing here that I could turn this wheel with Eds PMH by itself, having it on top here. And the reason it is set up on top here is because these magnets really, in one single row, not five, in one, the strength is going to be focused on the outside of the magnet. But when you start stacking these guys, the strength really is stronger. If you put like a C-clamp over these five stacked, the strength is really at the top and the bottom, and that's where they all kind of build their strength. Of course, there's strength out here, but I could take a compass and go over the compass, and pretty much you can see the compass pulling up or pulling down. It's only really focused maybe on the middle one here, okay? But it's more concentrated up top here. So if you take these magnets that are not really that strong, and it was one of the things where I had a lot of difficulties in the beginning of trying to understand how to get this wheel to turn without me turning it physically and without hooking a motor up to it. How do you get it to turn? Well, as I realized that if you look at this as not being magnets, but as being just metal, you could pull it. And basically, if you time the pull real good, you can get it to turn, okay? So pretty much that's one version of how to get Ed's wheel turning. And trust me, guys, it's monumental. I mean, it hasn't been done. This is the only replica of Ed's wheel out there that can turn. So just starters, okay? And this is not about demeaning Ed or anything about Ed on what he did with it. All this is showing that we can get the wheel turning. So today, you know, on some of the lessons learned here, one version of getting it turning was to throw some amps at it, okay? And you can force it to turn. So now I'm on phase 2 of that part of the thinking of, okay, well, I want to go back to the core reason I got into this machine was the pulse part of it. Now, having the pulse part of it being on the outside, pulling nothing but really metal, screwing up all my magnets, so I have to recharge them and reset them again, is one thing. Got it going, hooray, okay? So now we move on. So today, I was reading in Ed's book. And in Ed's book, let me see if I can pull it up here. Okay, so in Ed's book, he talks about to get the charge to jump into the coil. It'll force out of the metal to go into the coil. So that kind of gave me an idea. I said, let me stick a coil down here in the middle of the shaft. Because he's talking about when you take an iron core and stick it in a coil, now you're forcing the energy out of the metal into the coil. So I want to show you guys something. So here I got this 16 gauge wire. You got the core basically going down. Now this is one thing, but this is not even remotely close to even a fragment of the energy that I could produce once I wrap. I'm going to make a coil that fits in here that goes all the way to about a 1/4 inch away from the whole circumference from the inside of these V-shaped magnets. And right now I'm going to show you why we're going to do that. Okay. So what I realized was these weren't that strong. How to get them stronger. So I started going back in Ed's writings. And when you get to the part where he's building the PMH and he's showing off things that it could do, he talks about the iron core and the coil. So I started thinking about the whole wheel. I said, well, that's a lot of iron. That is an iron core, but there's no coil here. There is no coil. And if you look on his picture, you can't tell what's inside there. And you can't. But one thing I did notice, all the chains are magnetically locked together. They're not hanging freely. Gravity would be pulling them chains down. I don't know if you guys can see them, but they're all bunched up. So that's what happens when you send a good amperage, magnetic amperage into metal. It kind of crunches up like that. And you can see it's done, and he's turning the wheel. So I said, let's try this. So here I am, already done it. I'm still amazed on what I could do now. And I'm going to show you guys, this is how we got there. So we're back to this coil. Now when you put a good charge through this coil, what happens is two things. Let's go ahead and we're going to go ahead and put this sucker on. We'll work around the wheel a little bit. Alright, so here we go, guys. Bam, you can see you got nice magnetic current going through the center of this block. Hold on, my power just came out. Going through the center of this block. And it's strong, okay? Now notice that on this rim, on that rim, she's just floating there, okay? Just floating there, bouncing back up. It's because of the magnetic field that's put in here. Now the magnetic field that's in here, guess where it's going, guys? It's coming out the magnets. It's making the outside of these magnets stronger. So basically now, what I'm working on is to build the pulse motor of this magnetic motor, which will be so different than just slamming it on the outside and forcing it to turn. We are magnetically going to have this thing come alive with a lot of juice and then back down, alive and back down. It's going to get stronger and less strong. And what we're going to do is basically use the outside as the metal force. Because what's going to happen is when this wheel turns, it's going to want to get caught up into the line of magnetism here, from strong magnets to just metal, nothing else. But hold on, it may be that this would be a field magnet, but it'd be a field magnet with like 6 volts going through it, so it's very little. And what I'm trying to do here is induce the magnetic field from the inside of the wheel, and not so much from the outside here anymore. Because right now I'm inducing here like Superman strength. Trust me, guys, Superman strength to pull the wheel. If I do it from the inside here and have these magnets here getting stronger and less strong, because they are kind of weak. I'm not saying these guys are great lifting magnets, man. We got magnets today to kill them. But the good part of this is that these metal magnets here are weak enough to have a good field, but they can get strong again by inducting the inside of this wheel. So that's where we're going to go back to using the pipe on the side. I'm going to back the copper out of the top part of it, so the front part of these magnets have just the pipe running down the side of it with a nice distance. It has about a good 1.5 inch distance, you know. And I believe it's because he magnetically induced the charge on the magnets, and that would attract it towards the pipe. Now, I do have Eds Leedskalnins PMH here, and that's 1,500 turns on both sides, okay? And what we do is we run current through the PMH on both coils. We're going to run them in spontaneously at the same time. So basically we're coming in the starts of both of the coil, and we're coming out on both ends of the coils, okay, the same time. So we'll be using this as a timer. Now, there's a couple things here that I like about this, like, vision of looking at this wheel. If we can pulse the magnetic field and the strength of these magnets, all we have to do is put some amperage into them with the coil. You got so much metal here. You got a lot of backup of energy here that's it could grab from. By just having probably the pipe and the PMH on top without even using this, I'm sure if you got these two here, it would run. And then